Hi everyone, welcome back to the YouTube channel. I am Andrew Wang from the PML committee, and uh, today we are going to be going through the solutions for elementary school round 145. And so, yeah, let's start off with the first question. In an equation, when x equals 0, fx equals 2, when x equals 1 or -1, fx equals 3, and when x equals 2 or -2, fx or function of x equals 6. When x equals 3 or -3, fx equals 11. What's the positive value of x when fx equals 18? So first, we have read the question. Let's look at the question from the left screen right now, left side of the screen. So we basically wrote out all the formulas highlighted in blue. X equals what happens when x equals 0, function of x is what. Now we can sort of see a pattern where the as the x value goes up by 1 or goes down by 1, the fx value 2, 3, 6, and 11, it goes up by 1 from 2 to 3, then 3 from 6 to 3, and then 5 from 6 to 11. And this kind of indicates it might be a quadratic relationship. So we can put the quadratic formula and set fx, function of x, is equal to ax squared plus bx plus c. So now we can try out the different x values to see if we can get the values for a, b, and c using this quadratic formula. So when x equals 0, the function of x is ax squared plus bx plus c equals 2. And in the end, we get c equals 2. So it's a good sign that we already have c. Now, when we look at the next one, which is if x equals 1 or -1, the equation still remains the same, except ax squared plus bx plus c equals 3. And then from this, since when x equals 1, the result that we get is a plus b plus c equals 3, and we'll use these highlighted formulas later on, and you'll see why. The negative, using -1 also works for if x equals -1, but you'll just get something different, like a minus b plus c equals 3. And so we have c equals 2, a plus b plus c equals 3. Now let's try and find one more formula, since we have 3 unknowns, and therefore we will need at least 3 equations to find the unknowns. So if x equals 2 or -2, the function of x is same formula, ax squared plus bx plus c, but equal to 6 now, since from the top here, x equals 2 or -2, the function of x equals to 6. And if we use x equals 2 and substitute into the equation, we get 4a plus 2b plus c equals 6. But if we use -2, it sort of changes a bit, and it becomes 4a minus 2b plus c equals 6. And as same as the b one here, we will still use the +2 one, so it's 4a plus 2b plus c equals 6. Now that we have 3 equations and 3 unknowns, we can find the unknowns. So the 3 equations, as another rundown, is c equals 2, a plus b plus c equals 3, 4a plus 2b plus c equals 6. And so when we put c equals 2, when we put c equals 2 into the a plus b plus c equals 3 equation, we get a plus b plus 2 equals 3. Now it so solves out into a plus b equals 1. Now we'll only take out the 4a plus 2b plus c equals 6 side, and we narrow it down. C is still equal to 2. We substitute into the equation. Now 4a plus 2b equals 4. And now we divide the entire equation by 2. Everything's divided by 2, and we get 2a plus b equals 2. After doing this, we can subtract the equation 2a plus b equals 2 by a plus b equals 1. And what you'll get is actually the b cancels out. So it becomes a equals 2 minus 1, which equals to 1. So a equals 1. We now know the absolute value of one of the variables. Now, the other one we can find from this a plus b equals 1 equation. We already know that a equals 1, so b equals 1 minus a, which equals to 0. So b equals to 0. Now, since we now know a and b, we don't need to find c because c was already part of one of the three equations. So we have our three variables: a equals 1, b equals c, b equals 0, c equals 2, and this will help us find what the positive value of x is for the function of x equals 18. Now, let's take a look at the bottom here, last part. So function of x still equal to 18, and using the quadratic formula, which is ax squared plus bx plus using the quadratic, yeah. And then now we just substitute these variables inside. A is 1, so 1 times x squared plus 0 times x plus 2. Once you simplify that, it equals to x squared plus 2 back to the equal to 18. So x squared in the end equals to 16, and x equals 4 or negative 4, and therefore the positive value of x when a function of x equals 18 is 4. So the answer to this is going to be A, just like I have put up here. Any point in the video, if you just need to know the answer, you can always just look at the top here, the answer for all 6 questions. So now let's move on to the second question. Move on to the second question, which is, in a room where there are 5 people, how many handshakes would occur if everyone shook hands with every other person? So yeah, let's get right into it. So we're gonna set the different people as A, B, C, D, E, and these are the 5 people. So we are going to don't get confused with this. This is just the answer key, just a reminder. And so the 5 people are A, B, C, D, E, and we'll indicate the interaction by putting each letter with we will mimic the handshakes by putting the letters together. So when A and B handshake, we can represent it as AB and AC. So if everybody shakes hands with every other person, we will get AB. The AB handshake will happen. AC, AD, and AE. And now we will also have B shaking hands with C, B shaking hands with D, and B shaking hands with E. Now we will also have, you can sort of notice a pattern how the number of handshakes that happen per person. So with B as a starting letter, there's only 3 compared to A, which is AB, but we can't put BA anymore because that interaction already happened with AB. So now we move on to C. Yeah. So C hasn't shaken hands with D yet, so C and D will shake hands. And then C and E also haven't shaken hands yet. And then last interaction is between D and E. Yeah, D only has 1 when it is at the front here, and E doesn't have any because it's already shaken hands with everyone once. So if we count up the handshakes that have happened here, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 10 total handshakes. Therefore, the answer is the answer is E, 10 handshakes, as I've listed up here. So let's move on to the third question now. So third question, Professor Nelson has $63. Alfred has $2 more than Jenny, and Jenny has 1/3 as much as Professor Nelson. How many dollars does Alfred have? So for this question, we're going to set some variables. So N, we'll put N as Professor Nelson. N equals Professor Nelson. A we'll put as Alfred. We're just going by the first letters of their names. And J we'll put as Jenny. Yeah, that should be all. So we know that Professor Nelson has $63, so N equals 63. We also know that Alfred has $2 more than Jenny. So Jenny plus 2 will equal Alfred. So J plus 2 equals A. We can write it like so. A plus 2 equals A. We also know that Jenny has 1/3 as much as Professor Nelson, so we can write it out as J equals 1/3 of N. Now, remember from what I mentioned earlier, when we have 3 variables, we can easily solve it if we have 3 equations. So we have 3 equations and we have 3 variables, so it's a perfect situation. So let's solve for J first, because we will need to know J if we will need to know how much money Jenny has to know how much money Alfred has, which is the question. So we can first do J equals 1/3 of 63 of Professor Nelson's money, and 63 is Professor Nelson's money. Therefore, Jenny has $21. Yeah, $21. Since we know J equals 21, now we can find out how much Alfred has, which is how much Jenny has plus 2. So therefore 21 plus 2 equals A, and A equals to 23. So therefore, Alfred has $23, and so the answer will be D, I believe. So yeah, the answer to question number 3 is D once again. So now let's look at question 4 now. So it's a pretty short question. I can still read it out. So, which number is equivalent to 3 to the 4 over 3 to the 2? So let's erase question 3 first. Let's do that. And for this one, I can actually draw this out. I think it'd be easier. So 3 to the 4 over 3 to the 2. Three to the 4 over 3 to the 2. This fraction symbol can also be a division sign. So it'd be 3 to the 4 divided by 3 to the 2. And I don't know if many of you know this, but there is a power rule, which is a to the m divided by a to the n actually equals to a to the power of m minus n. So if we apply that here, the a is obviously 3, the m is 4, and the n is 2. So I'm just gonna undo that. 3 to the 4 divided by 3 to the 2. So this would technically be 3 to the 4 minus 2. And if we just focus on the top exponent here, we can solve it out to be 3 to the 2. 3 squared, just 3 squared. So now 3 squared, another way of saying this would be 9. Do we have a 9? Yep. So the answer to question 4 is 9, C, if you're looking for the letter code. So question 4, answer question 4 is C. Let's move on to question 5. Again, not a lot of dialogue. So solve for the area of the shape below when AF equals 5, FE equals 3, AB equals 7, and DC equals CB. So just so you guys have a better view of this diagram, I've already read the question. So it's basically question 5 right here. Right here. I'm going to circle it so it's easier to see. Okay, yeah. So solve the area of the shape below when AF equals 5, FE equals 3, AB equals 7, DC equals CB. So I can zoom in a bit more if it is needed. And basically it is this question. Just gonna clear this. So this is the diagram. So I'm gonna solve it on this side. AF equals 5. You know that. I can also provide some drawings along the way to help so it's easier to follow. So AF equals 5. Put a 5 here. And so we know that FE equals 3. And then AB equals 7. AB equals 7. And if you kind of see the this figure, it kind of looks like 2 rectangles. So I'm going to draw a line here. Draw this line. And so this actually helps us so it's easier to calculate the area. And okay, now let's get back to it. AB equals 7. We know that DC equals CB. So first things off, we need to find some numbers for, let's say, ED, DC, and CB. So we know that FE plus DC will equal 7. So 7 minus 3 equals DC. So DC equals 4. We also know that DC equals CB. So there we go. CB is also 4. And now the last dimension we need to figure out is ED. Now, if you kind of see this, FA equals 5 and CB equals 4. Assuming that this is a perfect rectangle. I didn't read the question properly, but if it is, then 5 minus 4, ED should be equal to 1. So we'll write this as 1. So now that we know all the values, it should be pretty clear how to calculate the area for this figure. So we can do it by the 2 rectangles. And if you didn't know, the area of a rectangle formula is base times height. Just base times height. And in this one, we have 2 rectangles. So we're going to have to use this formula 2 times. So in the smaller rectangle containing the points here, ABs, or we'll just set this as G. That's G. In the small rectangle containing F, E, G, and D, the base is 3. So 3 times the height, which is 1. And we have the area. But that's not the area of this entire figure because there's another rectangle, and which is the bigger rectangle with the vertices G, C, A, and B. And for the bigger rectangle, the base is 7 times the height, which is 4. And we have the entire area of this figure. So now we solve this. It equals to 3 plus 7 times 4 equals 28. 3 plus 28. And therefore, the area of this entire figure is 31. Here, I'll just clear all drawings. So therefore, the area of this figure is 31. And the answer is B. That's what I've written here. That is going to be all for this video on the Prairie Math League YouTube channel. Once again, these are the solutions for elementary school round 145. Question number 1 is A, question 2 E, question 3 D, question 4 C, question 5 B, and question 6 D. If you have any questions, don't hesitate to email prairie.mathleague@gmail.com. We will try our best to answer them. Once again, this is Andrew Wang from the PML committee, and I will see you next week for round 146.